So yes, welcome to the DataShield Newcomers workshop. I'm Alex Westerberg. I'm at Newcastle University along with my colleagues Dimitri and Stuart. We work on the DataShield team, so we help develop the software and help disseminate it out to new users and existing users on the forums, and provide support. So we're calling today's session a Newcomers workshop, just to emphasize this is for those of you who haven't seen DataShield in action before. It's not going to be too helpful if you already know how to use it and you want, say, to know how to customize a particular function. We do have drop-in sessions on an informal basis where you can come and ask us all sorts of tricky questions about how to use things. Hopefully, if you get into DataShield after the session, you will be keen to come and join us there. Also, our forums are available once you get to grips with the basics of DataShield, and you can use them to post questions in beginner areas, analyst areas, or even developer areas if you get to that stage. So, firstly, just checking we know what DataShield is. Well, it's in R. It's the R statistical language in which we have a set of R packages, which you will use to write commands, which then churn and whir and go off to the server and do the analysis of data. So important to note that we are open source at the moment, so you can view all of our code on GitHub if you would like to know how a particular function works. But how does all of that business at the server work? So the key thing to think of is that we are sending commands such as, for example, mean, and that is sent through the internet and arrives at the server where the data is stored, and functions on the server side run, and part of that function is a non-disclosive check. So we have written a function to actually compute the mean, but also run checks to make sure nothing comes back to you, the user, that will reveal things about the underlying data. The whole point of DataShield being that we are doing non-disclosive analysis. So you are limited on what you see returned to you, and you have to answer your question by inferring as much as you can from what is returned. So another thing is that it is often used in the medical context to look at individual level data. And obviously medical data can be very sensitive about patients' medical records or conditions. So DataShield is an ideal software to use in that context, because you won't get details about Joe Bloggs in a hospital in Germany. You will only be able to view aggregated results for, say, all of the patients with cancer A in Germany, for example. Lastly, I'd like to point out it is remotely hosted, so the data can be stored within the hospital. A computer hosting it can be set up with the DataShield software, and then you, the analyst, will type in a username and password and connect to that data to then run the analyses. So let's move on. We have an animation here of the moving parts of a DataShield analysis. So this really helped me when I first joined DataShield as a team member to understand where the commands are going, where the results are going. So flashing here is the symbol for us. I think that's actually the interconnect symbol, but it represents us, and we're in the north of the UK. And so I, as an analyst, decide to launch an analysis session, and that sticker figure is me. And then the data server, well, this can be anywhere in the world, as I just mentioned with the German hospitals example, but it's a computer with the data loaded onto it. The harmonization process has already occurred before it was uploaded there. If I, as the analyst, am allowed, I will be given the login details so that I can write the login command and send it to the server. So that sets up the session, and it allows me to then send commands and get aggregate results from that data. So that connection between the analyst and the data is known as the data shield session. So on that server, we have an R environment with some data stored in it. So next, I come up with this script, like if I want to know the mean of a sample and its variance and covariance, and possibly a table with some tests built into it. All of that can be written as a script and then run in this particular data shield syntax, and then gets sent through to the server. Then it gets loaded into the R environment and is applied to the data on the servers. And cogs were, and through the functions we've built into that R environment on the server, some results are generated. For example, this graph here. That's an example of an aggregated result where it's telling you some information about the sample or population as a whole, but without seeing individual level results. So that gets sent back to us, and only that. Simultaneously, if you choose to do so, you can have your script be sent out to all the other servers around the world, such as in America or Poland or France, anywhere like that. And they'll all come back to you. And then they will combine, if you command it to, into a meta-analysis of results. So you can both see the individual servers' results as well as the combined meta-analysis. So that brings me on to what we're going to do today. We're going to get to know this whole system by looking at some data I have already uploaded to Yannick's Opal training server, which is based in France. So I chose Titanic passenger data because it is freely available online, but also because it contains individual personal data. So the dataset I found was rows of names, passenger classes, location of embark, where they embarked, and whether they survived or died in the Titanic disaster. And then I randomly split this into two servers so we can understand how to run analyses on data that's stored in multiple locations on different servers. This is just synthetically done. It doesn't really mean anything, but it will be good practice. You could, if you like, think about this as if the Titanic tickets were bought from different ticket offices, then maybe each ticket office would have stored its own record of those purchases and stored them separately. And what we're going to do is watch me run some code consisting of data shield functions, and I'll explain along the way of what I'm doing. So over to RStudio. Can you see RStudio? Right. So to the top. So to start with, I hope you're all familiar with R, but what we are using here isn't just a regular R script, it's actually an RMarkdown script. So that is just a way of structuring formatted text. For example, you can create a bold or emphasized section using these asterisks, or you can create a code chunk that colors itself and formats itself in the correct way for a particular language, here R in the braces. Also, you can do things like create headings and subheadings using a particular number of hashes. So yes, this can be made available after our workshop in an HTML document format. So it looks like a document with all the code output built in. Another thing, I'll also make available the RMarkdown script as well as the HTML output. And if you want to run that yourself, you can put your cursor inside the code chunk like this, and then Control-Shift-Enter runs that particular code. And not in this case, because I've got a hash which comments out in R, but in most other cases, it will create the result below the gray area. So we've gone through the presentation of what DataShield is in concept, but then how do we actually go about using it, practically speaking? Well, because it's a set of R packages, you'll need to install them if you've never done that before. That's the command for you to do so when you run this script afterwards. I won't do that now because it does take some time and will slow down our demonstration, but that's all you need to run. Oh, I forgot to mention, as well as doing Control-Shift-Enter on highlights, you can also just use this green play button that runs all of the code in that code chunk. So once you've got them installed, as I have, I'm going to load them in using the library command, as I'm sure you all know. So there we go, no errors. And next, we need to actually connect with that data that I showed you in the animated diagram. And this data actually is stored remotely. It is on the server in France. So we need the URL, which Yannick has provided to us. And you need the username and the password. So I'm just going to quickly take us to the online portal. I need to change my share again. So I'm going to log out. So if you clicked on that link, this is where it would take you. So this is a login page. So I need the username, which is DS, abbreviation for DataShield user, and password is password, even though that's very insecure. It's just a demonstration, so it doesn't matter. Sign in. So here you will get the welcome dashboard. And the key thing to look at is explore data. So by clicking on that, you'll see all of the data sets stored on this server. The one we are interested in is the Titanic one, which I uploaded 3 hours ago. So by clicking on that, we can see in this table symbol to the left, we can see the actual servers within this project. So that's one table on one particular server, and that's one table on a different server. And we can see how many rows and, sorry, how many columns and how many rows for each data set. So it's nearly split perfectly in half, but I couldn't quite get it to do that. Clicking within that, you can find the metadata to understand the column headers, but we'll get to that in a second. Share. Newcomers Workshop Studio. So the first stage of any DataShield analysis will be your login data frame. So I'm going to explain the makeup of how this is built. So firstly, we're going to create a new object on the client side called builder, and going to assign to this using the DSI new login builder function. This will be available in many places on our wiki or forum, so you don't have to remember all this. You can just copy and paste it in and then customize the arguments contained within. So what are the arguments? Well, we're going to have server 1. So that's what we're going to be having appear on our printouts for the client-side results. So important to call that something logical, not just A or B, because then you could get lost. I'm going to call it Titanic server 1 and Titanic server 2. Then you need the URL that you've been provided to access the data, which was up here. And you need the username and password. But then you'll also need to know the table name as it was stored in the Opal portal. So the makeup of this is the first bit before the dot is the name of the project, which in my case was Titanic in lowercase, and then dot separating it from the server inside the project. And I called that Titanic server 1 when I uploaded it this morning. Lastly, you need Opal driver, but that doesn't change, that always goes there. So, yep, Titanic server 2, and the table is Titanic server 2. So that is built once you run it, and you also need to do this build function as well. So all of that run together creates your login credentials, basically, which then we're going to send it off to the server. So that is done using the datashield.login function within the DSI package. So some important things to highlight within this login function is, firstly, the logins argument needs to be pointed towards your login data that you just created up here. Assign equals true. I can't remember what that actually does. But the symbol, that's what you're going to actually see in your printouts as well. So you need it to refer to which object inside the table you're referring to. So say in a regular R analysis, you want to look at someone's height, you'll do data frame $height. Similarly, we're calling the data frame here on the server D. So I'm going to run all that, and it goes away to the server, logs in, and we have these progress bars here to show us that it's all worked. And no error messages. It is in red printout, but you would see an error occurring here if there was one. So that is what we're actually going to do now. We're going to try and generate an error. So I've made a mistake somewhere here in the login data frame, and now I'm going to run it all. So this is the error here. It doesn't look like it did before. Titanic server 1 is not accessible. Titanic server 2 will be excluded because the name is not accessible. So that means we have to return to our login builder and search for the mistake. And here I artificially made the mistake of calling it June 2020. So if you change that to 2021, run it all again. Oh, actually, it's still wrong because I've got the project name wrong. So what I need to do is call it Project Titanic, not Newcomers Workshop. Run all that. And this time it's worked. So no errors in that printout. So that comes to the end of the first section. Has there been any questions in chat? Or are there any questions? We can pause for a minute if you want to think of any.
I've got a question.
Okay.
You said those input values in the function on the top of the with the Opal driver.
Here.
You said Opal drivers always stays the same.
Okay.
Why didn't you have a default? Why didn't you have Opal driver as default value in that function then? Wouldn't it make more sense? Or do you have do you have a different drivers than Opal driver that do affect it in a different way that would matter for us? Or didn't you speak about because it's just a Newcomers course here?
There are multiple sets of drivers. There's one called DS Lite, which you can use for developing software, which is all within the client. There's also another one which is the driver for the for Armadillo. So we generally are using Opal, but there are other drivers available.
Okay, yeah. So basically, it was a bit of a mistake to say it always stays the same. It stays the same in the cases where we're logging into an Opal server. Yes, thank you. If there isn't anything else, I will continue on. But yeah, I'm going to keep pausing at the ends of sections. So do keep thinking of questions and chuck them into chat, and Dimitri will stop me and we can talk about them. Yeah. So now that we are in, we're going to do some simple commands to see what data there is on this server that we've logged into, and then do some statistics on it. So we want to work out the properties of these data, but we can't actually use the command head or any other command that actually looks at the first few rows of a data frame, because that would be disclosive. You'd be looking at an actual person's name and their particular point in boarding, or if they died or not. So all of this in a data shield context needs to be kept private, and we'll do that. And we'll find out about this data set in different ways by inference. So firstly, we'd want to know what the dimensions of the data frame is. So any data shield function that you're going to use is going to be prefixed by ds dot. So data shield, obviously ds. And then dim, it's often the case that a base R function has an analogy in data shield. We have over 100 functions built into data shield now. So you can go onto our help articles or our wiki, or you can load the manual and you can view which functions are available to use. And for every function, of course, there is a help article for it. So we're going to run that using the question mark. So run that. So within the DS base client package, we've got the help function for dsdim. So we're going to obviously give the dimensions for an art object. For the usage, we actually do need to specify the object we're looking at using this x equals argument. It's not just going to work, it's not going to have a default value to just run dsdim on, because it needs to be pointed at the server you are interested in. So for example, here we need to have dsdim, but we need to specify the data frame object we're looking at as x equals d. And these quotation marks around that are always necessary because our parser works in this way that they look at everything inside the quotations to send it off to the server. So you must not forget about putting some of your arguments that are being sent server side in quotations. Whereas arguments like the data sources, that is just looking at the connections object on the client side, so that doesn't need the quotation marks. So we're going to run just this line by doing Control-Shift-Enter. That didn't work, Control and Enter. Yes, Control and Enter just runs the line, Control-Shift-Enter runs the whole block. So this is confirming that we have 11 columns of 444 rows and 447 rows. So that is exactly as we saw it the case on the Opal portal viewed through the web browser. We don't have to look at all of the servers at once. We can just look at one particular server by doing this one in square brackets to only look at the first object of the list that is the connections client-side object. So we'll run that only, and there you go. You only see the results for server 1. So similarly, if you wanted to run the mean on just one particular server, you would specify it using these square brackets at the end of the data sources argument. So where are we going next with this? Well, perhaps we want to know, we know there are 11 columns, but what do each column contain? Well, column names will do that for us, ds.colnames. We're going to say we're looking at the data frame object D and remembering to specify all servers using data sources connections. So running that, and we get the column headers. But then we run into the problem of what do some of these mean? Name and sex might be obvious, but SIB-SP or P-arch or P-class might be less obvious. And obviously you don't want, or the data owner might not want unwieldy long column headers. So there is going to be a data dictionary, which you will look at on the Opal portal again. So I'm going to switch across to there. And this is what we saw earlier. So this is the dictionary which we will need, specifically the label. Some servers can actually have labels in multiple languages. So you can have English labels, but you might also have French labels or Dutch labels or German labels. That is down to your the data custodian. So some of the less obvious things. So what is it? SIB-SP, so number of siblings and or spouses of that person on board Titanic. So if there was a particular data entry who had SIB-SP as 3, then they might have had one sibling, well, 2 siblings and 1 spouse on board the Titanic. So yeah, we can keep coming back to this data dictionary if we have more questions in future about the particular properties of any of the columns. Switching back to RStudio. So this text is just explaining you that Opal portal if you're reading this later. So I've written this section what not to do. This is just making sure you integrate with the I suppose you could call it culture of a data shield analysis. So you obviously can't directly view the data. The whole point of data shield is analyzing, but not disclosing individual level data. So you have to come up with different roundabout solutions to answering your questions. And as you go along and get used to the functions that are available and of course those that are not available, you will come up with roundabout ways to find out the information you're interested in. What is possible in Data Shield? Well, we have the list here available on our wiki, so I'll go to that. And on this wiki article, it's it's organized into generally assign type functions and aggregate type functions. So I'll explain them in just a second, but some examples are DS names, DS call names, DS dim, also matrices, table functions, distribution generation functions like creating random normal variables. There's modeling like generalized linear modeling, or is that mixed effects LMER? Forgot. Variance, covariance, correlation. So this is something you can go into in your own time and work out what there is available. So to get back to our studio. Oh, and there is this, this function here if you want to just generate it locally without having to go into a web browser. But it's not, of course, organized. It's just alphabetical. So let's actually look at a particular column name. So the age of passengers could be interesting to look at. So firstly, how many missing values are in a particular column? So num.na will do that for you, ds.num.na. So we run that. And so we found that there are 87 results in Server 1, so 87 NAs in Server 1 and 90 NAs in Server 2. And then if we look at the length of that column, so 444, 447 in each one. So we can deduce that the number of non-missing is the difference between those two. So if we run what I've prepared earlier and then print the number of non-missing on each, so 357 in both. So complete cases will do something slightly different. It will look at the entire data frame and then strip out any row that has an NA anywhere in it. So, so all of those missing values in the age column, their entire row will be gone, but also like in passenger class, if that has any NAs as well, that will be gone too, and it will just narrow it down to just a data frame of only fully populated rows. So this is a good point to discuss assign type functions and aggregate type functions, which is a big distinction we make in DataShield because it makes the difference of what you see at the client side after you've run a function. So an assign type function, the key thing to remember is that you don't get actual results back. You only get the confirmation that it has worked. So the object has been created and you get to see its name here, d_complete.cases. And a validity check. Whereas the dimension, run that. So, sorry, I've got lost a bit here. Now that was making. Right, so yeah, this is the actual output of what that complete cases was. So it's now got, well, it's still got 11 columns, but it's been reduced to 87 rows on the first server and 96 rows on the second server. So a lot of data has been chopped out by that. So here we are demonstrating an example of an aggregate type function, because some actual numbers, some results have been returned to the client side here on my computer and printed out for us to view, meaning that the functions on the server side have deemed that it is not disclosive to do so. So on slightly more disclosive functions, like if you squared all the values of a vector, then of course you could undo that action and that would be disclosive. And so such functions would be assigned type because they'd only create it on the server and wouldn't return you the results to your client side. Now, the other thing I was intending to show you here, but I explained it in slightly the wrong order, is trying to address particular objects that we've just created. So in this one where we created a new object of just complete cases, we were told what its name was. But that new object was not stored inside the data frame D on the servers. It actually created an all new object. So this is demonstrated by actually trying to address age underscore complete cases within data frame D. And of course, you get the error. Whereas by running this chunk, by addressing it as its completely separate own entity within the server, not D dollar anything, it's just D underscore, that was its name, then you do get a successful printout. So that is the end of aggregate and assign type functions and the basic syntax. Are there any more questions? I'll just give you a minute again, just in case you want to type in chat. If there isn't anything, I will keep going, and there will of course be a breakout question and answer section at 4 o'clock UK time. So the rest of my demonstration should only take us up to the hour, and then we'll have plenty of time for questions that you come up with. So to actually explore the data, so what kind of our object are we looking at in a particular column? Here we're going to look at the embarked column. So we're going to run the ds.class command addressing the object embarked inside the D data frame, and then specifying data sources, as always, is a good habit. So we'll run that, and we see that it is a factor object. So that would be perfect for us to have a look at it in a table. How do we use the table? We're going to use the help function. So it has the capability of one-dimensional up to three-dimensional contingency tables within DataShield. And I'll show you at the bottom is also, oh, not in this one. In most other help functions, there is an example at the very bottom. So you can see an example I'll print out of what it should look like for you. Other things to note are the default variables, some descriptions of what each argument does, and some details about the nitty-gritty of how a function actually works, which might help you understand why or why not a command is working for you on your particular data. So let's actually see a one-dimensional contingency table in action. We're going to only be looking at the first server here as specified by the square brackets 1, and we're looking at the embarked column. So what's this telling us? So 71% on Titanic server 1 embarked at location S, and 80% at C, 10% at Q. But what does that really mean? Well, we need the data dictionary again for that, so I'll quickly tab across to it. So, I thought I must have made a mistake setting up this morning, but this data dictionary ought to tell us that S is Southampton, C is Cherbourg, and Q is Queenstown in Ireland, I believe. I'll have to check that ready for the next month's demonstration. Anyway, I am tabbing back to our studio. But the point standing that in general, if you want to understand a bit more about an output, you will need to go to the dictionary, which is stored on the online portal. So as well as the proportions, there will also be the roll counts, provided that they are not a form of disclosure. So for example, if there had been only 2 passengers who had boarded at Queenstown in Ireland, then that would have been far too low here, as dictated by the parameters set by the data custodian at the server. And so not only would this not have printed, this particular table entry, but the entire table would not have returned to the analyst or the client side, because you could have done some calculations to work out, well, if the number boarding in Ireland was so low, then you could take the number boarding at Southampton and Cherbourg and take that from the total number and work it out. So in actual fact, if a disclosure error occurs, then the entire table is blocked, and that's just to be completely sure of non-disclosure within DataShield. The table command also sets things out in the other orientation, so reading across instead of down, at the end of which we get a validity message. If it hadn't been valid, then the tables wouldn't have been printed and we would have got an error in this place. How about a two-way contingency table? So I've already set one up to look at the number surviving against the passenger class. So let's see what that looks like. So here we're going to see that of the passenger, well, first class passengers, 15% died, and sorry, that's looking at it the wrong way, isn't it? So of those who did not survive, 15% were first class, 18% second class, and 66% third class. Whereas if you go below and read it in the other orientation, then you can say of first class, 37% did not survive, 63% did survive, etc. So there are two sections of this. There are this orientation and then this orientation. And each one is read slightly differently because each one has a different focus. So of this, then this many died. So no errors reported because all of the raw counts were sufficiently high that no disclosure occurred and there's no errors within the underlying data. We'll just quickly create a code chunk here. And we will check the table help and have a look at the chi-squared arguments. So by default, report chi-square test is false, but you can set that to true, and then you will be able to run a chi-square test on any of these tables. So more details can be found here. So they apply to every two-dimensional table in the output. So you will have to search through that output to find the one you are interested in. So moving on from tables to just descriptive statistics, remind ourselves of the column names. So yes, doing a mean on a numerical variable like age will probably be the most interesting thing. So slight difference in means between server 1 and server 2. This printout table does remind us of how many missing values there are and how many valid results it is calculating the mean from. That might be important if, say, the number valid was very low, so your mean was not very representative. Other ways of measuring central tendency. Well, for example, if you want the median, you actually want the function called quantile mean, because this is a function that creates the mean and the quantiles, including the 50th quantile, which is the median. So a lot of printout here telling you that it is working, but the black meaning that it's the result that you just generated. So by default, this one actually runs in a pooled way. So this is the results for both of the servers together. So our median for both servers is an age of 29, and the mean is ever so slightly higher than that. And then on the second command I wrote, it was using the argument split. So it's looked at the servers individually. And we can see that there is a bit of a difference here. On server 1, the median age is a little bit lower than the median age on server 2. So that could tell us a bit about the skew or the shape of the distribution. So there are actually functions in DataShield plotting to actually view these distributions. Start off with histogram. So we're going to look at the age column within the DataFrame and firstly look at a combined one and then let that argument lapse, so we look at split ones. So in an RMarkdown results, you can actually view the printout in like raw form, but you can also see the plots in different tabs along here. So the first one was combined. So that's interesting. So a lack of children generally, but then a strong skew towards the younger age brackets, like people in their 20s. And there is also the option of looking at them separately, and there doesn't look to be too much difference here. Slight difference in accounts, I suppose. Dimitri, would you mind explaining about the invalid cells? I think you explained that last time.
Yes, basically, I was trying to respond to one question on the chat, which is related to that. On the server side, we have some, let me send my response, but I will explain it. On the server side, we have some disclosure control filters. And depending on the functions, we use some of those on different functions. For example, in tables, we have an end filter which is by default equal to 3. So when the table is generated on the server side, the function checks if all the cells of that table have more than 3 counts. If at least one cell has less than 3 counts, the table is blocked and is not passed back to the client. So here, for the histogram, we use the same filter as we use on the table. And the histogram is created on the, basically the information that we need to create the histogram are created on the server side. And in order to create a histogram, you need to divide the range of a variable in bins. So you divide the whole range in bins, and then you measure how many counts you have in each bin. So if there are any bins with less than k observations, and by default this k is equal to 3, then those bins are not displayed in the histogram. But because the histogram is created on the client side, the information about those bins is not returned back, and therefore we don't know where those bins are. So this message here, it says that for the second study, so the second histogram here, we have one invalid cell. So it means that there is one bin of that histogram, which includes less than 3 observations, but we don't know where this bin is. So looking on this histogram should be in one of the 2 sides, but we don't know if it's on the right or on the left. For server 1, we don't have invalid cells. So this is the histogram that we get from, anyway, if we do the actual analysis on the client side, we are going to get the same histogram. But we also apply a small random noise on the minimum and maximum just to avoid getting the actual values of those 2 extreme values. Yeah, that's it about disclosure controls. But depending on the function, we have different filters. For example, for GLM, for regression, we have another filter that it checks if the number of variables in the model is less than a specific proportion of the number of rows in your data set. So we have around 9 or 10 of those filters, and are used differently on the functions.
Yeah, thank you.
Excuse me, can I ask?
Yeah.
Or later? No.
Yeah.
And how can you change the default value of the filters? I mean,
Yeah.
if I want to change the value of 3 to 5 or to 1,
yeah.
how can you change?
Yeah, Alex, can you show the Opal interface?
Yes, just so you're aware, it is currently on a user mode. So I don't know if you want me to log into administrator mode.
Okay, yeah. Basically, if you are on this interface, if you have administration rights, there should be a section where you can see all the functions, and above these functions, there is another section about options. And you can see the default values there. And next to each default value, there is a button, I think either is called remove or delete. And you can delete this value or edit. I don't remember exactly the name, but when you click edit, for example, you can change the default value. And if you run analysis on multiple cohorts, you don't need to have the same values in all the cohorts. And you can still, for example, some cohorts might allow to have the default values equal to 1, and some other cohorts equal to 3, but you can still get a combined table. Can you click data shield?
Oh, yeah.
Data shield. Remain, wait, go up.
This is the new Opal, so you'll need to select the option. So if you go down a little bit, there's options.
Yeah.
Yes.
Yeah. Okay. So it's edit. If you do edit, you click one edit, Alex, and then you can change this value and save it. And in some cases, you need to do that. For example, if you want to analyze, let's say, rare diseases, if you have only few people with some features, in most of the cases, in that case, if you run different type of analysis, you get, you have disclosure, and therefore you don't get results. And in that cases, you might decide to change these filters.
And this can be done by table, not in general, but if you have one table that, or that one project that you want to change this default value, you can do it.
Yeah,
For
basically, yeah.
I think it's only per user basis, I think.
Oh, because, yeah, sorry. Go. What I want to say, because this is a new version of Opal, and you can you can select, for example, a set of functions that are available to each user, or select specific options that I'm not sure about the options. So,
but this is possible. This is okay. Thank you very much.
Yeah.
Sorry, Stuart.
No, that's right.
If you want to say anything.
No, I think that's right. It's the very latest version of Opal. It's you can set up profiles. They can give different users a different profile, which will define what operations and what data sources they have access to.
Yeah, but the question from Albert is, if you have multiple tables within one Opal and you want to give access to one user to all of those tables, can you use different options for each?
I don't believe you can. I think it would be, the options would be applied to all the tables.
Yeah.
Okay, so we'll just push on to the end, and then there'll be time for final questions. So we're just gonna, now that we've seen histograms and described the non-disclosure settings of histograms, we'll look at the other graphs. As well as scatterplot, there are heat map and contour plot, but scatterplot is the most recent and is probably the most familiar. So we'll run this. Oh yes, this is where, as I've written to myself, this is an example of where skipping the data sources connections has gone wrong. So here we do need to specify data sources connections as a mandatory argument. So we'll run the bottom line instead. And here we can see the fare paid plotted against age. So there's not too much to infer about this. So the most expensive fare was by someone in their 30s. But what's very important to note is that you can't say that the most expensive fare was paid by someone who is exactly 25.6 years old, because there is a process that has taken place on the server side where every actual data point has been randomized. And there's two methods of doing this. If we look at the help function of this, so there's a deterministic method which looks at k nearest neighbors. So creates a polygon around every point and replots it as the average of its nearest neighbors. And there's also a probabilistic method which will just put random noise in a random direction. So while you can see the general shape of your plot, you can't really say anything about particular points on it, because that's just a generalization. But this method works because we have found out that this method will keep the general properties such as like slope, or the slope of a best fit line, or the amount of error contained in it. So Yeah, this is a very useful tool for visualizing plots, but without giving away any of the underlying data. So, and as a final note, if you've wondered if you can use ggplot on any of these plots that we've shown you today, it is possible, and there are some tutorials, I think, available on our wiki. And hopefully it will be a subject of future workshops for how we go through this process. Essentially, the way these plots are generated is on the client side, and it receives from the server a whole list of pre-generated points to plot these dots at. And so instead of just feeding them straight into the data function, you could just use this return.coordinates function and set as true, and you could use the resultant vector or data frame, I'm not quite sure which it is, to create your own ggplot and make it look prettier if that is what you want to do. At the very end, I want to point out to you that we don't actually have to end our data shield session and lose all of this work. You can actually save the workspace using this datashield.workspace_save command. So looking at the help function for that, so you need to remember the connections name that we've been using throughout, and then also specify a custom workspace name. Here we're going to use it, we're going to rename that as 2021.07.16. That's the date today, Titanic demonstration. We'll run all of that. And then after you finish your analysis, you'd log out. So that's an important step to get off the server and free up resources for other analysts if they want to be running their commands. But if you want to get back on and get all of that work back, then you can use the connections object as we saw above in the login data frame builder. But instead of doing datashield.login as before, we'll use the restore argument, and we'll quote the name that we created just above. So if we run those two, and then we run ds.ls, ls lists all the objects on the server side, and we will see that they're Stuart, how should I be reading this? I thought there would be two objects here. Oh, it's because I've restored the wrong one, isn't it? Live code editing. So if we
I'm glad you spotted that, because I don't think I would have.
So we'll run that one instead. And there we go. Yes. So we found two objects. We found the main data frame D and the other object we created to demonstrate assign versus aggregate, which is called d_complete.cases. That's the case in both servers. So you could have saved like a specific mean value that you wanted to use later, or you could have saved a particular generalized linear model or any of that kind of thing. Yeah, and you can come back to this later and continue where you left off. So that is the end of the demonstration. Any further questions?
Actually, Alex, thank you for the presentation. I do have a question, but it's maybe a bit outside of really the code in R and how to get all this information from different servers. But it's more before that, and it's about anonymization. Of course, you only get aggregated information in the end and not the actual data from different servers in different countries. But our legal counsel said, yeah, still the people using those servers for these analysis in DataShield and Opal, they need to be anonymized before other people can even send out a sort of algorithm to analyze and to get the mean, for example, just that you said in the beginning of this presentation. Do you know something about that part of, yeah, because it's really something we are discussing about with our legal counsel, and he still says it's still a sort of processing from one country who has set up a server and sends out sort of algorithm to get the aggregated data, and it's still data processing. Do you know something about that, or anyone in your team about these kind of legal and anonymization things?
We have, well, that's one of the kind of GDPR regulations.
Yeah.
And well, if your data officer requires you to do that, there's nothing to stop. You can still use DataShield on that anonymized data. That's not a problem. So if that's what they require you to do, yeah, that's fine. You can anonymize it and then deploy it into Opal. We are in the process of trying to gain advice from people and understand people's experience, so that we can collate together a document which will describe the best way to approach your data officer with the evidence to say, look, we believe that, for example, Article 89 is okay because of this feature of DataShield. So we're in the process of putting that together, but it's it's a work in progress.
Work in progress. Okay, well, that's great to hear. And I think, indeed, in the meantime, there's nothing against our approach to be extra safe and putting it on the server when it's anonymized already. And then, otherwise, he says, you have to have a sort of processing agreement between all partners or parties across all these countries that we work together with. So there's also nothing against it, but it's a lot of work to do that. And I was thinking maybe there's another way around. But if DataShield is working on these kind of facilitation, then it's really great. Yeah.
Well, that's one of our ambitions is to provide the people who want to use DataShield with support when engaging with both their technical people to explain what they need when they need to deploy the system, and also when they engage with their data governance people to assist both those processes.
That's great. Also for the technical side, for the because that is also something that I'm a little bit struggling with in my department here. People saying, you have to download everything. It's open source. You can all put it together on your own, and that will be great. Thank you.
I noticed there was a question about where the workspaces are saved. They are actually saved in the server. So you can save your client side workspace in a normal R manner. But this is a way of actually storing the corresponding workspace for your session in the server as well.
Okay, yes, because I was wondering about because in the workspace is the history of all the codes and the data that is returned from the servers, but also in the history of the codes there is the passwords and usernames. Maybe is it not a problem?
Well, on the server, the workspace just contains the data which you've loaded in and any derived data But naturally, all that data could potentially be disclosive. Therefore, you can't give it to the user. It is all served or saved in the server and can only be accessed via data shield's operations.
Okay, thank you.
Can I just comment about anonymization? The current consortia that use data shield, they do what is called pseudonymization, which means that they remove the direct identifiers like name or ID, and then they upload their data. When you want to do anonymization in all the other variables, this is a step before data shield, but you need to be careful that you minimize the disclosure risk, but you also minimize the information that you lose. So for example, if you want to anonymize data by adding noise, if you add enough, if you add noise, a high level noise, you might you might lose the features, the statistical features of your data. So this is something which is important. And in all the techniques that exist for anonymization, no one is the optimal. And in all the papers about anonymization, they say that the decision depends on your data situation. So every time, depending on your data, you need to decide which method to use. But other than that, a lot of cohorts are using data shield by uploading their pseudonymized data. And for example, in Netherlands, I'm not sure if you know the Generation R birth cohort.
I know it.
Yeah, they are using data shield through Lifecycle, for example, or other projects, and they don't have any issues up to
No,
now.
I'm planning to contact them. Yeah, thank you for the
And I think also Gecko is from the Netherlands. There is another cohort which is called Gecko.
I'm not familiar with that one.
It's a small cohort, but I think it's from the Netherlands.
Generation R, and I'm thinking about how his name is. But indeed, this group makes also use of data shields. Yeah.
Mm.
If there are no other questions, we're going to put all of these materials up online. I'm going to create a new post on the Data Shield homepage. You can click to scroll down to news. So you can access the download for the R script, the RMarkdown script. You can get the slides if you want to access any of the URLs mentioned. And you can use the links to the forums as well to sign up if you have any questions to ask further. So yeah, it's been lovely to see you all. Oh yes, Elaine, we'd love to hear your feedback. So that's in the chat. Anything about whether we've gone fast enough, we've gone too slow, anything and everything we'd like to hear. Thank you. Okay, stopping the recording.